Okay, so we have a Razer Blade Pro. I believe it's the 2017 model, RZ09022202, and it doesn't turn on, so we're gonna take it apart and see what the problem is. And since I don't have a camera stand for this, I'm gonna have to just film in segments, so I'll be back as soon as I get the cover off. It smells really burnt, and if you could take a look at the DCN section right here, you can see that the DCN cable is not even there anymore. It's totally has burned. See, totally burned up on the board here. So first thing I'm interested in is let's check see if that fuse is good, and while we're at it, we'll get the rest, what remains of this connector, off the board. So we got the board out here, and I'm sorry if I didn't show the whole process of getting the board out, but it's as simple as removing the screws and taking the board out. And if you can't do that, then you probably shouldn't be working on the device anyway. So right here is where we're interested in. I'm just going to take a bunch of flux right on there with my tweezers and hot air, and I'm just going to remove that connector, see if I can get that off and clean up the area a bit. So. Yeah, it just doesn't want to. Can see here that these pads are just this whole layer is just lifting up off the board with the solder pads. So I just have that one probe there in ground, and the other probe right here. If you see, this side is actually ground, see? Okay, and this side right here is good. It's not, see, it has high resistance. So this is the power side, and it doesn't seem to be shorted. It seems to be okay, actually. So probably all these components here in the input of DCN are pretty good and okay. But first things first, we're not going to be able to mount another connector on here, that's for sure. So we're going to have to do a modification to get this working. I'll show you that in 1 minute. First thing I'm going to do is just clean up the general board area with some alcohol and cotton. So I ended up replacing a few of these diodes and then put a DC in, because when I was actually cleaning it, a couple broke off because they were burned so bad. So I just pulled those from my donor board. I'm not even sure what values they are, but they'd be at least 30 volt and quite a few amps. Anyway, I got the pads here all cleaned up. Now what I'm going to do is I'm basically going to run a solder bridge on each side and just put all those little pads, connect each side together, so connect all those ground pads together as one, all these power pads together as one, and then I'll probably run a wire from there to the voltage side of this. So I got some 16 gauge wire here, which should be good enough for this job. I just need to check the length and make sure that the length of wire that I'm going to put on here to replace the wires on the original DC port are going to be long enough. So this should definitely be long enough, and I can cut it as well once I get one end on there if I need to shorten it. So I'm going to bridge each side of that for the ground over there, and then for the power here, and then probably also connect it to a fuse just for better connection on the power. And then I'm going to run wires directly from the one big ground pad and the one big power pad, and then I'm going to solder the other end of the wires onto the DC in jack right here to replace these original ones. I'll put some heat shrink tubing on there, make it look real professional, and yeah, it'll probably work. But before I do that, to power it, once I get the wire soldered on there, I'm going to hook it directly up to my DC power supply over here, just to make sure that it functions without issues before I go soldering the other end of the wires onto the port. So, because the customer did not send their charger. Alright, so Alright, you can see this has a really good connection here to power. Now since those pads were lifted up, it was still good and everything with the pads, but they were lifted up a bit. So I made sure to put a lot of solder on there, and then also bridged it right over to this fuse, just to give it better structural stability. And then on the ground post over here, I even used, aside from just the normal ground pads on the connector, the edge post, mating post to the board, to secure it in the end. Those are also ground, so I just connected all those together to get the best ground connection that I could, and to cover as much area as I could. So this is a really solid connection. And the first thing we're going to do is attach a DC power supply to the other ends of the wires at 20 volts, and I'll maybe limit the current to say 3 amps or so. That should be enough for it to turn on, and we'll see if it turns on. So ignore my desk, it's a bit messy, but I got some connectors hooked up here and here, and the other end right into this DC supply. So I'm going to turn this on and see what happens. Alright, so let's turn this on. Alright, voltage. Hold on, limited current. Voltage. Let's see what it does. Not pulling any current. It's good. We're going to need about 19. Okay, there it goes. At about 19. Let me turn the current limit up a little. Okay, let's hit the power button. Current spiked. That's good. Let's see if we get an image. Wow, that screen's dirty. See if we get an image here. Should have an image. You can see voltage, current. Should be powering on, but let's see, it's not. Wait, we got a green light. Flashing green light. Sometimes after you repair these things, you gotta, especially because the CMOS battery was unplugged, sometimes they need reset and they go through a cycle like this for a minute or so before the first turn on after repair. So I'll just give it a minute. And there it is. So we got image. Now I'm gonna now that I know that this works, I'm gonna plug the I'm gonna shut this off right now. I'm going to plug the battery in. I'm gonna make sure that it's charging the battery while it's off, make sure it's charging the battery while it's on, and if it does both of those things, I'm gonna finish wiring things up to connector here. And then I'll do a final assembly, and then I'll put it through all the final stress tests, and if it's good, then it's good. So we'll see. So here's the finished repair. Everything worked correctly. I got the battery plugged in. It's charging the battery, runs off battery, passed all the stress tests. So all I did was I took these wires here and I soldered them to the appropriate area on the connector here after removing the old wires. And then you can kind of see here, took a piece of heat shrink tubing that I had on there, and I pushed it up flush against the DC jack, and then heated it up, and it's all nice and tight around there in the ends. And then also a small piece of Kapton tape right there, as well as a piece of Kapton tape right here. So this Kapton tape will just to cover this up and to protect this area and everything. But yeah, everything works really good. This repair was a success. Now the battery is a bit bloated here. I'll have to see if the customer wants to replace this or not. The battery does work okay, but yeah, it is kind of bloated. It kind of should be replaced, but I'll leave that up to them. So, alright, thanks for watching.